Assalamualaikum and salam sejahtera. I am Nur Azmirawati Awang from Polytechnic Muazzam Shah. Would like to present our innovasi product on cellulose nanocrystal nanoparticles as novel green engine oil additive. To begin with, let's go through with the introduction part first. Environmental sustainability is a challenge that is viewed on a global scale. In order to respond to the challenge in the automotive industry, various initiatives focus around sustainability tracking, reduce energy costs, increase renewable energy use, and innovations in product offering should start being implemented by automakers and manufacturers. One of the factors of energy dumping in automotive industries is friction between moving elements that lubricants are used in order to decrease this friction. Even modern internal combustion engines convert only 1/3 of the energy in fuel into useful work. The rest is lost to waste heat, the heat friction of moving engine parts, or to pumping air into and out of the engine. All of the steps at which energy is wasted are opportunities for advanced technologies to increase fuel economy. Of the energy content in a gallon of petrol, 62% is lost to engine friction, engine pumping losses, and to waste heat. Therefore, the reduction of friction and wear of cylinder liner and piston ring assembly is essential not only for increasing life of the IC engine but also beneficial for reducing fuel consumption and emission. Nanoparticles additives have been used as a new formula to improve the properties of lubricating oil. Dispersion of nanosized material enhances thermal physical properties but provokes three critical problems that includes high sedimentation, leads to poor stability, hazards to the environment, and dangerous to human health. In order to create sustainable future and to minimize the negative environmental impact, nanocellulose are being increasingly explored as candidates to replace conventional nanomaterials due to its ready availability, biodegradability, and biocompatibility. Cellulose nanocrystal is a green and renewable material which is composed of nano-sized cellulose fibril with a high aspect ratio. Cellulose nanocrystal are bio-based materials that can be derived from plants or bacteria and in general from a variety of highly available and renewable cellulose resources of the most abundant natural polymers. To develop the potential green additive of cellulose CNC nanoparticles, it is necessary to understand and quantify their influence with engine oil SAE40. Next is the problem statement. Dispersion of nano-sized material enhances thermal physical properties but provokes three critical problems that includes high sedimentation, leads to poor stability, hazard to the environment, and dangerous to human health. The objective for this is to determine the best thermal-physical properties such as kinematic viscosity, viscosity index, thermal conductivity, and specific heat using green oil additive in internal combustion engine. The next part is materials and methods. In the study, the engine oil SAE40 was used as a base oil and CNC were procured from Blue Goose Biorefineries Inc. with weight concentration at 7.4%. The CNC then was synthesized into the powder form. Spray drying was conducted using a laboratory scale blower and was performed in a conditioned room with relative temperature was 31 Celsius. The suspensions are quickly evaporated with the hot air flow through the orifice of the blower nozzle, resulting into a stable CNC flakes form. The CNC flakes were ground manually into powder form using porcelain mortar for 30 minutes to make sure the CNC are evenly ground. CNC nanoparticles were suspended in base lubricant at different concentration to formulate the corresponding nanolubricants such as 0.1, 0.3, 0.5, 0.7, and 0.9 weight% as shown in figure. The nanolubricants were then agitated using an ultrasonic shaker for 1 hour in order to ensure uniform dispersion and good suspension stability. Thermal physical properties for nanolubricants such as kinematic viscosity, viscosity index, specific heat, and thermal conductivity were determined. Kinematic viscosity using standard ASTM 445, while viscosity index 6 based on standard ASTM 2270. For the result, a nanocellulose nanocrystal nanoparticles were proposed as a green additive in the fully formulated engine oil of grade SAE 40 under varying concentrations of 0.1 to 0.9% of nanoparticles in lubricating oil. This involved investigating the CNC's nanolubricants of stability and thermal physical properties. Through this experiment, the figure part 1 shows results for stability investigation using sedimentation and ultraviolet near-infrared spectrophotometer. Stability validation after sedimentation after 3 weeks of preparation shows that nanoparticles dispersed in lubricant oil have greater stability in samples of less than 0.5% of the CNCs. Compared with all sample concentration, it observed that 0.9% nanolubricant exhibited higher absorbance of 4.58 at 250 nanometer. Figure part 2, result for thermal physical properties such as kinematic viscosity, viscosity index, thermal conductivity, and specific heat capacity. For physical properties, it can be said that nanolubricant of CNC particles at 0.1 weight% concentration was the most suitable concentration for improving properties of SAE 40 engine oil. The thermal conductivity for all concentration is higher than base oil, and the best thermal 0.9% volume is the optimum concentration for better specific heat capacity and thermal conductivity. The next part is the novelty, high thermal conductivity enhancement by 6.6%, 2.5% higher viscosity index than base oil, and environmentally friendly. Last but not least is the beneficiaries or expected market that includes automobile industries, green environment, employment, and enhanced skilled workers. That is all for the presentation. Hopefully this video will be beneficial to everyone. And with that, thank you.